Hi, this is Rabat, and now we will try to solve this bubble sort problem. The problem states that the given piece of code sorts the array in big theta n square time in both worst case and best case. We have to enhance the code in such a way that the best case time complexity improves to big theta of n. We know how bubble sort works from the previous course, therefore we will not get to the detail of its working. We will directly jump to the time complexity. So here is the algorithm. If we feed this algorithm the worst input, let's say 4321, where the array elements are totally in a reverse manner, the time complexity will be big theta or big O of n squared. Let's see how. I starts from 0, and so as j. When the element at j is greater than the element at j plus 1, we do a swap. Therefore, while the inner loop runs, there will be a swap every time. When the inner loop ends, the number 4, so the numbers we were dealing with were 4, 3, 2, and 1. So when the inner loop ends, that is when j ends, both I and j started from 0, and every time there was a swap. So at the end of the inner loop, the number 4, which is the largest number, will sit at the end. So after the inner loop, my array will look like 3, 2, 1, and 4. I will now increase by 1. So I was initially at index number 0. Now I will be at index number 2. And j again, which is the inner loop, will start from 0. And this time j will run up to this particular index again, as every time the element at position j is larger than the element at position j plus 1, there will be a swap. Like the previous time, now 3 will sit at the second last position. This will continue until the end of the first loop. Okay, so this is my outer loop. So this swapping will continue until the end of the outer loop. And when the outer loop ends, I will have the numbers in a sorted manner. Now let us calculate the time complexity. So we have a table with 3 columns. The first column is I, the second is j, and the third is the number of iterations. When I was 0 initially, the inner loop j ran from 0 to n minus 1, which is n minus 1 times. When I increased to 1, j started from 1 again, j started from 0 again, and run up to n minus 2, the second last index, and therefore the number of iterations is n minus 2. Similarly, when I became n minus 1, j started from 0 and it ended at index number 1, which is there was just one iteration. The time complexity is basically the summation of the number of iterations. So we have n minus 1 plus n minus 2 plus up to 1. And this can be written as 1 plus 2 plus up to n minus 1. Now, this is nothing but an arithmetic progression series where we have to find the summation of n terms. And this is nothing but big theta of n squared. So this algorithm proves that the time complexity is big theta of n squared when we give the algorithm the worst possible input scenario. So this was our input, and the time complexity is big theta of n squared. Now we will find out the time complexity when we feed the algorithm the best possible input combination. So 1, 2, 3, 4, which is an array sorted already, is the best possible input combination. But before that, let's look at the algorithm a little closely. You see, the number of loops running, so these are the loops I have. So the number of loops running does not depend on whether the element at j is bigger or the number at element j plus 1 is bigger. Which means, even if this condition is true or false, these two loops will always run to its fullest. So to clarify, even if, let's say, we remove these two lines. So even if you remove these two lines, these two loops, I and j, will run exactly that many times if these lines existed, which proves that the combination of the elements does not really matter. Hence, we can say that no matter what the input is given to this algorithm, whether it's a worst case input or the best case input, this given algorithm will take the same amount of time, which is big theta of n squared. Now the question is, we have to make it better, okay? But only the best case scenario. Now how to solve it? So let's take an array with the best case scenario. Let's say we have the numbers 10, 20, 30, 40, and 50. Now for this best case scenario, do you see that there will be no swaps for this element j? So let's see. Let's call the element k instead of j. Let's erase this. So 10 is smaller than 20, 10 is smaller than 30, 10 is smaller than 40, and 10 is also smaller than 50. Therefore, there will be no swaps. Now, if this is position j, and this is position j plus 1, according to algorithm that we saw previously, bubble sort algorithm, this if condition will never be satisfied. Now, as there are no swaps for the first element of this array, can we say that the array is already sorted. Now, before we answer this question, let's try to answer another question. Again, if the first element is never swapped, do we really need to swap the other elements, the other remaining elements? Now, if you look at this array again, so we check 10, the first element, with all the numbers, and we see that we didn't have to swap 10. As a result, now if we look at the remaining numbers, we do not have to swap any number. We do not have to swap 20 because 20 is smaller than the rest of the numbers. We do not have to swap 30 because 30 is smaller than the rest of the numbers. We do not have to swap 40 because 40 is smaller than the remaining number 50, and 50 is the last number of this array. So can we say that if we don't have to swap the first number, the rest of the array or the entire array is sorted? And can we say it blindly? Can we say it without checking? So can we answer this question even without checking? And the answer is yes. So what we have to do is we have to check. So we just have to run the loop one time to check that if the first number has a swap or not. If the first number doesn't swap a single time, we do not have to run the loop again. We can simply say that the array is sorted. Now, if we look at the algorithm, so let me clean it a bit. Now, if you look at the algorithm, my inner loop, so I'll start with the outer loop, and my inner loop will run for one circle or one cycle, checking if the first number swaps or not, which is basically this condition. And if this condition is never satisfied, we can simply say that the array is sorted and we can completely end my algorithm. So if we run this algorithm, or if we do this, or if we work according to what I said, my inner loop will run one time full cycle, which is n amount of time, because I have to do a check for the first time. As there are n elements, there will be n number of checks. And if this if condition is never satisfied, we can simply end both these loops. And the time complexity will be big theta of n, because we just have to run this algorithm one time, which is basically there will be n amount of iterations. Now, can you solve it? You just have to check or use a flag to see if this condition is ever met or not. Thank you very much.